Okay, in today's tutorial we will be training DETR, end-to-end object detection with transformer model on custom dataset. Instead of training the model on Cocoa dataset, lots of people ask questions about how to train this DETR model on custom dataset. There are lots of useful comments. If you have any questions, I suggest you read the comments in this issue. Okay, so what we're going to do is, instead of training this DETR model on Cocoa dataset, we will be training the model on wider face, a face detection dataset. I'll provide the link on the description, and you guys can go there and download these three images. Train, validation, and test images. Make sure you also download this face annotations, because this is where ground truth box annotation of the images are in. So for me, I already downloaded the files in this dataset folder. If you see here, you have 4 folders, and the wider face split contains the ground truth in 2 formats, text or in matrix format. Yeah. And under each folder it has images, and in each folder it has image that contains lots and lots of faces taken in different places. So you have running, picture taken during running, and you have baseball as well. So before training, what we have to do first is we have to convert this ground truth images and ground truth bounding boxes into Cocoa format, because that makes us easier to train this model. We have to change this into Cocoa format. So if you see this face to cocoa.py, I wrote this code before the tutorial. So if you see here, this Python script converts this ground truth and images into Cocoa format. Let's just briefly go through the code. So first we have to define number of categories. In our tutorial, it's just one category, which is the face, and it's a list of categories. So it's going to be super category is going to be none, name. It's going to name of the category. It's going to be face, and the ID of this category is going to be 0. And once we have that, we put it into this rest file, which in later will save this into a JSON file. So we have categories in here, and what we're going to do next is, for each image dataset and ground truth boxes in each images, we are going to store each images into this image list and each box into this annotation list. So for image, we have here an image element. It's going to store the file name. For example, it's going to be, the file name could be, let's say, parade marching band underscore 1 or underscore 5, and that's going to be go in here. And we also store the information of height and width of an image. Also, we have a distinct image ID. Once we have this image element, we add this image element into the images list. Okay, that's for the image. And for each bounding box, what we do is we also assign a distinct annotation ID, and we define bounding box, which is top left point and width and height of a bounding box, face bounding box. And here we define segmentation. For our tutorial, we're not going to use this, but I just added as list of points. but we won't be using this in our tutorial. And also we have this image ID. This image ID should match image ID right here, so it shows where this bounding box belongs to, so where this bounding box is in which image this bounding box belongs to. And ignore we set it to 0, category ID we set it to 0 as well, because remember that category that we defined earlier is defined, it has an ID of 0, so in case you want to, in case you set this to another number, let's say 1, then you have to define category ID 1 here as well. And isCrowd we have 0, and area it's simply width times height of a bounding box. And once we have for each bounding box element, we add this into the annotations list. And once we fill in all the images and bounding box annotations, we save this res file into the JSON file, which is down here. Before running this code, remember that I have here max n equals to 10. I'm using this variable to just consider images that has number of faces less than 10, because I ran this code and the distribution of so the possible maximum number of faces in this dataset is 1,900 something, and the number is too large, because if we see here in detection transformer, number of box queries, number of queries is set to 100. I think it can be increased to 250 or till 500, but a number close to 2,000, I think that's going to be a problem. So what I did here is I set the limit of faces that an image could have, which is 10. So if number of boxes in an image is greater than max n, which is 10, I just skip that sample. Okay, let's try to run this code. Let's go to, instead of doing this, let's go to this dataset, open terminal, and Python 3 phase 2 Cocoa. Let's run that, and done. So we processed about 10,000 training images and 2,500 validation images. If we see here, we have train.json and validation.json, and we'll be using these two ground truth and Cocoa format annotations in to train the model. Okay, next step, we have to download the code, which is here. Let's clone this. Let's clone this in this folder instead of dataset. Let's git clone DETR. Okay, now that we have DETR code, let's enter the virtual environment that I created earlier. Source free and bin activate. We have that. Before changing the code, I'll show you my settings. Pip3 freeze torch. I'm using Torch version 1.5 and Torch Vision version 0.6. And NVDSMI. I have a small GPU. Where is it? GeForce GTX 1660. It has a RAM of about 6 gigs. And it has a memory of 6 gigs. And driver version is here, and CUDA version 10.2. Okay, let's move into the code. Okay, I'll be using Sublime. I usually work using Vim, but just for this tutorial I'm just gonna use Sublime. DETR. Let's open this. Yeah. So first what we're going to do is we are going to make a loader for face dataset. So cocoa.py is a loader for Cocoa dataset. So we're going to make a copy of cocoa.py. We're going to name it as copy cocoa.py to, let's name it face.py, and we have a new file here. So first let's change all the names. Let's find all cocoa. Let's see if there's an easier way. Replace cocoa to face, replace all. But we shouldn't change this. Yeah. And let's see. Move down, and under build, what we're going to do is, instead of face path, let's name it data path. And we should change this later in main as well. So what we're going to do is change these lines of code. So root is going to it's going to be the path to the dataset, training dataset. So base path to the training dataset. So it's going to be this path. So we don't need this because we don't have that folder in this directory. Just set it to root for validations as well. Remove that. Instead, we are going to have, for training, we're going to have wider train, because that's the name of the training folder. Under train, we have also images. We name it like that. Validation as well. Wider val images. And, well, this is the base path for the image. And this here is the path to the JSON file. So it's going to be base path. We don't have annotations folder, so we just remove that. And instead of mode train 2017, that's for Cocoa, we simply have train.json. The same goes for the validation JSON file, which is going to be val.json. Once we have that, that's all for the face.py, and we also have to change something in init.py, which is here it calls, depending on the dataset file, it calls a builder, but we don't have one for face, so let's add that. If args dataset file equals face, the return, let's name it build face image set args, and here we have to call the builder. Instead of Cocoa, we call it from face, import build as build face. Now that's all for datasets. Now let's move to main.py. We have to change some of the base parameters. First, we have to change, where is it? Number of queries. So in original code, in the paper as well, number of queries is set to 100, but remember that we are trying to consider only faces of size 10. So what we're going to do is we are going to change this number to 10. And remember we changed what was the name? Under face.py, this args, originally this was cocoa.path, but we changed it to data.path. So under main, let's find Cocoa underscore path, which is here. Let's change that argument to data path. Okay. Now under main, that's it, I guess. Let's move to the models DETR.py. What we have to do here is we have to change the number of classes, which is defined under build function. So for Cocoa, it uses classes of size 91, else its number of classes equal to 20, but instead of having this, let's add a new line of code. If args dataset file equals face, then number of classes equals 1, because we only have a face class. If in the paper it also detects no object class, but we just set number of class equals to 1, because later in the code, within the code, it adds 1 to consider it handle no object class. For here, just have 1 here. Okay, I guess that should run. That should run without errors, hopefully. Let's try to run the code. Okay. DETR hyphen main.py. Let's see the name, so the arguments that we have to set. First, we have to set dataset file. Instead of Cocoa, we set it to face, and data path to the path where it has this train JSON and val JSON, which is dataset. Yeah, and we also need to have output directory, which is, I'm just gonna name it as output. Let's try to run this code. Oh. This has to be Python 3. No module name py face tools. Okay, under face we changed all Cocoa to face. I think that caused the problem. Cocoa tools. Okay, looks like it's running okay. So right now, let's stop that for the moment. This line of code, what it does is it's training the model from scratch. But if we train the model from scratch, if estimated time for a single epoch is about 30 minutes, and people say that to get some good results, we need to train the model at least for 100 epochs. But that's going to take more than a day. So what we're going to do is, instead of training from scratch, let's go to this link and download, under Model Zoo, there's this pre-trained DETR with ResNet 50 backbone trained on Cocoa dataset. So let's save this model into documents, tutorials, DETR. Let's create a new folder here. Name it weights and save the weight file. Let's wait for a bit. It takes a few seconds. Once we have that, what we can do is, when we train the code, when we run the training code, we add resume weights path to the checkpoint file. If we run this, it's going to cause error because the checkpoint file has class output size of 92, which is for Cocoa dataset, but we have 2 for our face dataset. And input query as well. In the weight file, it has of size 100 by 256, but since we reduced the number of queries to 10, it's going to we're going to have a mismatch. So what we're going to do is move to main.py and look for the point where the model's being resumed, which is here. What you're going to do is, at this point, before the weights are loaded into the model, what we're going to do is we are going to delete some of the weights. We have to delete checkpoint model. We have to delete this class embed weight. Let's have that. We also have to delete class embed bias. And lastly, we have to delete query embed weight. That's all. So with these 3 lines of code, it's going to, before loading the weight into the model, it's going to delete some of the weights that causes mismatch. But if we run this code, it's going to give us an error again because within this model it has class embed weight, class embed bias, and query embed weight, but it's not able to find these weights from this pre-trained weight. So what we're going to do is just strict false. So it's just going to ignore this and just run training. So if we run that in a single GPU, it's running with no problem. So yeah, so if we do this, if we instead of training from scratch, if we resume training from pre-trained model, I think training it for about 1 or 2 epochs should give some results. So yeah, we could do that, but my GPU right now is really small. It only has 6 gigabytes of RAM. So what I'm going to do is I'm just going to train this code in another computer which has a larger GPU, and hopefully it's going to train well, and let's see if the code works correctly. Okay, so I've trained the model for only 2 epochs, and I have the weights in this output folder, checkpoint.pth, and let's see if the results are okay. And while waiting for training, I wrote a test script where you can visualize the images. So I'll provide this into the Git repository that I'm going to make, so just use it. Yeah, so let's test the code. Here, so Python 3, test.py, let's see the arguments. Dataset, data path is going to be a path to test images, so it's going to be dataset test wider test images. So that folder contains all the test images, and we'll resume from output checkpoint.pth. If we run that, we get the results. For this image, we have more than 10 faces, so let's just skip that. Yeah, so the results looks okay. You only trained it for 2 epochs, and we're getting these results. So I think this is good. This image as well. We're missing some faces, but I think if we run it for, well, this one has lots of faces. The number of curves should be at least, I think, 100 to detect all the faces in here. So just skip that. Well, we see that some overlapping faces, overlapping boxes, but I think if we run the training for, let's say, 10 or 20 epochs, I think the quality of the bounding boxes is going to get better. Yeah, I think that's it then. That's all for this tutorial. Next time I'll come back with another interesting tutorial. That's all for today, and I'll see you next time.